So, good morning, namaste, and vanakkam.
Good morning.
Yeah, and thank you. We had a very pleasant and nice interaction yesterday. And let's continue from where we left off the previous class. So, I began my discussions about resources, okay? And we had a discussion about human resources. I must mention that when we talk about human resources, it's a very vast subject. Human resources management deals with the entire cycle of human resources management. I mean, if one really wishes, you could go back to even the preschool. The new education policy talks about human resource development. I mean, even from preschool, and lifelong learning. We never stop learning. As a teacher, I'm a student for life, a very formal student for life. Okay. It's my right and my duty to continue learning. But we have tried to compress everything into just one session. So you should understand that obviously there'll be serious limitations in what I had shared with you, but hopefully whatever I had shared would be relevant to our context of maintenance management. And you also know that there are universities that offer full postgraduate programs in human resources management. So today we'll come to the next resource. You may recall that we talked of 5 basic resources, which you had recounted in the last time we met. Human resources, financial resources, technology, infrastructure, and material resources, then organizational and managerial resources, and finally, networks and relationships. You may also recall an earlier discussion when I pointed out that the first 4 are internal to the organization, primarily or predominantly, okay? Whereas the last one, networks and relationships, is predominantly external to the organization. But these are all very important in the journey of the organization, in the work that the organization does, and particularly with a focus on the outcomes, the mission, vision, objectives, and goals. So these resources provide the basic inputs to help the organization transform them into those outputs. But don't forget the feedback loop also, which we had drawn in the diagram. Fine. So when we talk of financial resources, again, you can consider them into 2. One is short term, the other is long term. I mean, in terms of time. I mean, there are many aspects connected with financial resources. Again, financial management is also a very big area. There are full-scale postgraduate programs in financial management. Obviously, we're not going to touch upon everything. We might be able to compress it in a very limited way, which is at least good enough for a starting point for your understanding. Okay. So, what do we mean by short term and long term here? Sometimes people refer to the short term as working capital and long term as investment capital. I mean, the finances that you have for making investments or potentially holding them for making investments and so on. Okay, so short term and long term. Working capital means money that you need for daily work. Daily you need some money to roll. You need to pay some bills and so on. Sometimes people call it operational funds and stock funds. I mean, stock means not stocks and shares, but something that you hold. So there are mostly I've come across the terms working capital and investment capital. Okay, obviously, let me confess, I'm not a big expert in finance. I mean, the courses I've done in finance belong to my master's days. And at best, I can claim that I've done some courses on cost accounting towards the ICWA certification, which I did not sit for the exam finally because my PhD was happening at that time. Nevertheless, so I'm not a total stranger to the world of finance. Now, I hope all of you agree that you need a combination of both. You need cash in hand, working capital, and you need finances for the long term also. And this is very, very important because you need that kind of a arrangement so that you are able to have the cash flow happening in the organization. So the cash flow is something like the blood flow in the human body. The cash flow in an organization is something like blood flow in the human body. It keeps the organization well lubricated, if you want, if you wish to have an analogy. Of course, there's another flow also which is very critical in organizations, which is information flow. And because we will move ahead a little faster on this, let me also share with you that I am aware of some news on how companies shut down because their working capital isn't very strong. They may be all right with the respect to their long-term capital. Of course, working capital finance itself is a subject. There are many MBA programs that offer a course on working capital management. So it's not just that you can't say just because your long term is very good, your short term will be automatically all right. We shouldn't make that kind of an assumption. You need a nice balance between the two. And finances are also important because we often talk about return on investment. So what's the return on investment? Of course, it leads you into very interesting subjects like time value of money, where you hold the principle that a rupee today is better than a rupee tomorrow. Okay? And that's where you talk about interest rates and depreciation and so many other things connected with your physical resources. And this becomes very important as you dive down into the world of finance, because after all, every rupee that you put into your maintenance effort in an organization has to pay off in terms of availability of the equipment. I hope you agree, because we did discuss much earlier in our course that an equipment that's not running means money that's not flowing. You may recall that instance I told you. There's a businessman who's making 90 crores per hour or something like that, or perhaps per minute. I don't know. I don't recall whether it was a minute or an hour. But you're talking of that kind of a magnitude of money flow, depending on what kind of business you are in. So please remember, time is money. So availability has to be maximized. So naturally, a good question that will be asked by financial managers in the organization is, okay, we've invested so much in maintenance. Well, what are the returns? What could have been the returns? What's your performance like? So that's the subject of maintenance performance evaluation, which I had mentioned to you. We will discuss a little later in the course. Okay, I'll use that as a bridge before we go into data analysis, right? So please don't forget these aspects: return on investment, costs that you are incurring in running the maintenance function. So like this, there are many concepts related to finance. Of course, we are not here to make you masters in finance, but you must know some basic concepts like double entry accounting or double entry bookkeeping, as they say. You must know what's the cash flow statement. You must know what's a profit and loss statement. You must know what's a balance sheet consisting of assets and liabilities. You must get exposed to basic reading of a balance sheet of a company, and you must know what is equity. You must know what is debt. Like this, there are many fine topics in finance. Okay, and I hope you will get some interest in that and start general reading, so that you have some general knowledge about the world of finance. Of course, we also talk about borrowings and so on, payment back, interest rates, and so on. Okay. I'm not going to go further on this topic, but we will discuss the next resource, which is technology, infrastructure, and materials. Okay. Now, in this particular case, when we talk of technology, infrastructure, and materials, there is something interesting that is of direct relevance. I mean, absolutely what you work with. Okay? So we'll go a little in detail here. Infrastructure and materials. Now, technology, infrastructure, and materials, again, we can classify in terms of capital equipment and consumables, because you can look at it in terms of capital equipment and consumables. Okay, your machines, your instruments, all of them will fall under capital equipment, the first one. And you have many consumables. It could be, sometimes they call as waste cloth, which you use for cleaning and all. Your oiling, your oil, like that. There are many consumables, including stationery that you may use for the maintenance function, paper and stationery, etc. So we differentiate between capital equipment and consumables in this case. But there are other things which you have to bother about when you're working, especially in the maintenance function, and you're dealing with capital equipment especially. Okay? So one of the views of technology, this is something that we must understand, is that we always differentiate between science, engineering, and technology. Again, I'm not going into the philosophical aspects, but very broadly speaking, you can categorize them as science consists of knowledge of the universe around us in terms of various laws that we observe, certain conditions and so on, conditions, laws and rules and so on. Okay, so science is predominantly knowledge, and engineering predominantly is action, expenditure of energy to achieve certain objectives. I shouldn't say achieve objectives, I should say achieve goals and fulfill objectives, while pursuing mission and realizing a vision. Okay, we will keep that same structure. While you want to fulfill some objectives, you engage in the action of engineering. Obviously, the action of engineering is based on the knowledge of science, right? So science consists of making a lot of observations and ensuring that what we observe is replicable and shared by everybody else, so that you can get to proofs. So you can get to common understanding of the universe around us. So I'll put it broadly that way, because there are some basic principles that have to be followed, and replicability, verifiability, and one of the most important principles is falsifiability. See, unless some proposition or something is falsifiable, you would not call that science. Okay? It might be dogma. It might just be blind belief that somebody has. So again, we are not going into the philosophical aspects. As I told you, this body of knowledge in science feeds into the action of engineering to enable us to produce various things for our purposes. It may be to do with comfort, convenience, some functionality, and so on. To differentiate technology, we often say technology consists of things, embedded with the knowledge of science and the action of engineering. Okay, so you can always talk of this model, which I'm trying to share this with you, so that in this particular case, which you're going to directly deal with in your work, okay, finance you will deal with, but there are others who will take care of finance. You may have to supply some information to them to work out everything to do with your financial efficiency with which you're performing the maintenance function. That's why I didn't dive into finance, but I would urge you to sort of get yourself some general knowledge about finance. But this is something where you directly dive into. This concerns your work, because when you say maximize availability as the core objective of maintenance, you're dealing with technology directly. Okay, it's your bread and butter. It's your nuts and bolts, if you want to put it that way. Okay, you can look at this model, which might be helpful to you. Okay, I'll just science, engineering, technology. Okay, I put technology at the apex because there are two things that happen. Okay, you have human society. Again, it's a picture. It's always good to understand certain parts of knowledge using pictures. Okay, so you have human society, and then you have, on the other hand, you have the natural environment. is technology, science and engineering. And these two are interacting with each other. And you also have this interaction. So I hope you got the picture. You have science and engineering as a base in this model, okay, on the base on which technology is brought forth. Okay? And then that technology has interactions, two-way interactions with human society and natural environment. Technology influences or has direct interactions with both. Okay? So we, for example, here, the interaction between technology and human society is broadly categorized into the body of knowledge called technology assessment. Okay? Now, this is important. And when we talk of the notion of sustainability, I did mention this earlier to you, if you recall, survival, stability, strength, success, superiority, and sustainability. When we talk about sustainability, maintenance becomes a very critical aspect in the realization of sustainability. There are some basic principles in sustainability, and all of them are linked to the idea of technology. So we will talk about all that. We talk about recycling, recovery and repairs and so on. Okay. So, and obviously this technology on natural environment comes under the body of knowledge called environmental impact assessment. Okay. So, and this one, human society on natural environment and human society, I mean, I would use the term general studies, for want of a better term. I'm sure somebody might have a much better term to classify that. I would even prefer to use the word systemic studies, or systems studies, or systems approach, systems thinking, systems studies, if you want to put it that way. Okay. So if you wish to have a term, I'll call it SS, system studies. This model is important for us because it has a bearing on your work with technology and infrastructure materials, especially. Trying to minimize wastage of materials, trying to maximize utilization of technology, and in whatever way you can. Now, once you have this mental model, I'm just summarizing, you view science as a body of, predominantly as a body of knowledge dealing with nature and the world around us, and understanding it commonly so that everybody can see the same thing, agree with what's happening, you have some good references. Then you have engineering, which can be understood in terms of the actions that we perform to create some things, and the actions are based on the knowledge of science. And then you look at technology as those things that are embedded with the knowledge of science and the action of engineering. Okay. Now, is it necessary for those things to be physical objects? Not necessarily. Okay. Although people come out with some other views of technology, technoware, orgaware, infoware, and so on, I do not subscribe to that model, okay? Because I believe ultimately we have to look at technology. I mean, I'll put it this way so that it's very simple for you. In the world around us, we have technology and we have nature. That's all. I'll put it that way. Either something is technology, which is human made, or something is natural. In this room, there are some things that are natural. The light, I mean, the colors that you see, and so on. You and me, of course, you are virtually there. I'm here. We are all natural. Okay? I will not say, okay, philosophically, somebody say, come on, LSG, you are also man-made. You are made by your parents. Okay? But then it leads us into something else. So I'm not going to get into those discussions right now. But we take ourselves as part and parcel of nature as it is. Whereas the chair, the blackboard, the chalk in my hand, my spectacles, these are clearly not in nature. So these are man-made. So we have technology. By the way, this is also technology. The pen is also technology. The chalk is also technology. I mean, the moment we use the word technology, please do not imagine always very, very sophisticated technologies. Simple technologies are there. The pencil also is technology. So we get into things like active technology, passive technology, and so on. Again, no diving into that. So technology can be viewed as things embedded with the knowledge of science and the action of engineering. Okay, so you see this relationship, they are all interrelated. Okay, today in the modern world that we live in, it's almost impossible to engage in scientific activity without technology and engineering. Today, it is almost impossible to engage in engineering without science and without technology. And likewise for technology, it's almost impossible to talk of technology without the knowledge of science and the action of engineering. Okay? Of course, in a generic way, I could even suggest this should give you an idea between the differences between BSc, BE, and BTech. Okay? You can extend that. Again, that's not our interest, but I thought I'll at least share with you. If somebody asks you what's the difference between BE and BTech, you have a basis at least. Of course, there'll be a huge intersection. If you draw Venn diagrams, there'll be a huge intersection. So don't forget the intersections, right? Technology is also, and even infrastructure can be understood in terms of functional capabilities. Okay? I'm writing this here on the side, functional capabilities. Now, what are these functional capabilities? We produce technology, we make technology in order to provide us with some functional capabilities. Now, what are those functional capabilities? I'll ask a simple question. I just now said the pen is a technology. It involves technology. It's an object that can be classified under technology. Now, what are the functional capabilities of a pen? Why do you think a pen is made? To serve what purpose for us?
Writing.
Yeah, of course, the answer is correct. So be careful. The pen doesn't write, we write. So the pen is an instrument that enables us to write, correct? So it has its own technology. It has its own parts. Okay. So we have to be very, very clear about that. For example, I think I may have done this for you. I can disassemble the pen completely, isn't it? I can disassemble the pen. I take off the parts and I have that here with me. So I have the cap, I have the head stopper, I have the refill, and I have the body, isn't it? So I can disassemble the pen and I put them together. I get the functionality of a whole pen. That it's an instrument that enables us to write. Very simple. This is technology. But it involves the knowledge of science and the action of engineering. The pen is made through some engineering. Some machine has been used to make this pen. And some science is there in the chemistry of ink, the flow of ink, etc. Some science is there in terms of the forces that the pen can handle, the stresses. Otherwise, it will break. Isn't it? Something to do with the refill, the flexibility, the corrosion that could happen, etc. So there is that knowledge of science. So functional capabilities. The primary functional capability of a pen is that it should enable us to write, which means there must be this instrument which enables flow of ink at a certain rate, and then the qualities of ink are also there, whether it's whether it will dissolve in water or it won't. So when you take an ink pen and write on paper and water comes, you know your writing can go. Whereas when you do that with a ball pen, it doesn't do that. So you look at all those kind of qualities, isn't it? So functional capabilities. What are the functional capabilities of a motorcycle? That I'm sure all of you would have ridden motorcycles. What are the functional capabilities of a motorcycle?
It enables us to travel one place to another place.
Yeah,
More.
sure.
Yeah.
Fine, that's a good answer. It's a machine that enables you to travel from one place to another at a certain speed, let's say. Okay, but there are other functional capabilities also. Your answer is very correct. The primary purpose for which anybody would buy a motorcycle or rent a motorcycle is for transportation, personal transportation. Okay, fine. Any other functional capability available with the motorcycle? Remember, even pens have many functional capabilities nowadays. You could have sophisticated pens that on the other side have a pen drive, or could even have a clock. You have multi-color pens and so on. So there are different functional capabilities even in the context of differently designed pens, right? Some pens have a torch, small torch at the other end, and so on. Or the laser thing that you can use while making presentations, the laser pointer, and so on. Likewise, in a motorcycle, what are the other common functional capabilities? One is enabling you to transport yourself, assuming you are riding the motorcycle. Yeah. What are the other functional capabilities? Yeah.
Headlights of the motorcycle.
Pardon?
The headlights of the motorcycle.
Yeah, the light. Anything else? It's very interesting, but there's something even simpler, Aryaman.
Horn.
Yeah, the horn. Something even simpler. You're right. Your answers are correct. Creating the sound to enable safety on the road. What else?
Sir, seat.
Yeah, I mean, the speed is a functional capability that's part of your transportation.
Sir, indicators.
Indicators. I mean, very good. You're giving me right answers. What about steering? What about braking? And what about a geared cycle, geared motorcycle? I'm not talking of ungeared ones. Geared motorcycles, shifting of gears, braking, isn't it? Do you agree? And there are many other functional capabilities. For example, heat transfer from the fins in the engine to the atmosphere, so the engine is kept relatively cooler. So there are many such fine functional capabilities, including today exhaust, so that you conform to BS6 norms, Bharat Standard 6 norms. I hope you understand this example. So obviously the motorcycle is a far more sophisticated technology in terms of the differences in its functional capabilities and the way they work together in harmony to provide you with safe and comfortable transportation. Okay. And compared to the pen is much simpler compared to the motorcycle in terms of what it can do. I'm not talking of pens used by James Bond. Now, I'm sure if you see James Bond films, you'll see some very really fantastic applications of a pen. Okay. I'm just talking of simple pens that you and I have and motorcycles. So functional capabilities are very, very important in understanding technology. Why am I spending time? Very simple. When do you engage in breakdown maintenance?
When there is some problem in functional.
Exactly. What is that problem? Do you agree it's a loss of a functional capability?
Yes, sir.
So the moment somebody senses that a machine is not sort of providing the functional capability it's meant to do, you have a problem at hand. It calls for maintenance. Now, I hope you understand. So that's why very often what happens is in maintenance work, people also have some kind of fault tree analysis charts. So they reason out various faults that could be based on some symptoms on the machine or what you observe as a maintenance expert. You can trace the fault using the functional capabilities analysis. You can analyze how functional capabilities are related to each other. So I hope you understand why this discussion is important. So you can prepare for every machine, you can prepare a functional capabilities chart and their interactions. At this stage, maybe I'll also expose you to another idea which is important from the point of view of maintenance. How do you view an engineered system, a technology? It's a simple hierarchy which you can use. So I'll write it here. So at the top level, you have the system, the whole system, which offers all the functional capabilities that are needed, that are designed. So you can take the motorcycle or a car, you have the whole system. Then you have something called a subsystem. Even in your maintenance practice, you can use this kind of a simple understanding. You have the whole system, the machine. Then you have a subsystem. Can you name any subsystem in a car?
Like a AC
Air
in a car.
conditioning.
Pardon?
Transmission system.
Okay, a transmission subsystem, if you wish to put it that way. Okay, transmission subsystem. Then you have something called the module. Okay, then you have something called the unit, and then you have something called assembly, and then component, and finally you have part. So this kind of understanding of technology in terms of systems, subsystems, modules, units, assembly, components and parts could be useful to you. Okay. Now let me try to explain. Like you said, transmission subsystem. Now this, sometimes people combine these two. Okay, sometimes they say a subsystem and a module are about the same. We not get into those finer aspects. I mean, there are people who differ in a fine way, but we need not get into that. I'll just tell you in a very simple way, the system is that technology, that machine, which offers all the functional capabilities which it is designed for. Okay, it's a fully working system. Now, what's a subsystem or a module? Depending, if you assume that you can interchange the terms, a module is that part of that system which will offer a subset of the functional capabilities. Are we clear? Full system will offer all the functional capabilities. A module or a subsystem will offer a part of a subset of those functional capabilities. So now you understood why we said transmission subsystem, braking subsystem, steering subsystem, and so on. Okay. Or even the power subsystem, the cooling subsystem, okay, the structural subsystem. And so there are many subsystems, and these are integrated to form the system and provide all the functional capabilities. Now, what's the difference between a module or a subsystem on the one hand and the unit? The term unit means it gives one functional capability, a unit functional capability. I hope you got the conceptual difference. A subsystem or a module will offer a subset of functional capabilities. A unit will offer a single functional capability. That's why it's called unit. Then the unit is made of assembly. It is assembled together. So an assembly will not give functional capabilities, but is a necessary part of the unit to provide the functional capability. In fact, I would like to give you some work, not from the point of view of examinations or something. Try to take any object like the car or any other machine you can think of, a washing machine at home or a refrigerator at home, okay, or if you're an electronics engineer, take a TV, or a visual display unit, and then or a computer, and then try to use this model and see what is the whole system, what is a subsystem, what is a module, and what is a unit, and what's an assembly. I hope you differentiated between unit and assembly. Unit will offer a functional capability by itself. With provision of energy, it will give that single functional capability. Okay. Assembly will not yield any functional capability, but is a structurally necessary component of the unit. Assembly is made of components, and components are made of parts. okay, unit parts. Parts cannot be subdivided further. If you want to subdivide a part, there's no meaning in it. For example, even in my, if you take my pen, so I will say this, using this definition, the cap is a component. You know why? Because the cap has a couple of parts. It has the clip which is fitted into the cap body, and then you have a stopper on the top. The stopper on the top is a part. I can remove it. I hope you understand this. Similarly, in the refill is a component. If you get the idea. Can anybody tell me why the refill? Actually, the refill is an assembly. It's more than a component. Can anybody tell me why you will normally call it a refill assembly? I explained to you. Yeah. What is the difference between an assembly, a component, and a part? Yeah. See, we get an assembly when you assemble components, correct? In fact, you can go straight from parts to an assembly also, skipping components if you wish. That depends on the technology you're dealing with, the machine you're dealing with. Is that clear?
Yes, sir.
Yeah. So, can you tell me why would we call the refill an assembly?
Because
Sir,
sir, it has a
Because
refill ink and the pointer through which we write.
yeah, so what
And
if the refill is an assembly, at least tell me what are the parts that go to make the refill, that are joined together to make the refill.
sir, a small thin pipe in which the ink
You
is
have
filled.
you have the tube, okay, and
Yes,
then
sir.
the ink is stored in
Ink
the
is
tube.
filled. Ink is stored, and
Yeah.
we take a pointer, a small
Well,
ball.
that's the writing tip actually. The
Yes, sir.
writing tip has a what do you call, a neck and a nozzle,
Yes, sir.
and there is a ball inside the nozzle which is rolling.
Yes, sir.
Correct?
Yes, sir.
And then you have at the other end of the refill, you have a stopper. Correct? You have a stopper at the other end of the refill. Very often you will see that. Even in normal simple refills, you will find some kind of fiber attached to the other end, put into the refill. Okay. And if it's a ballpoint pen, which is a typical, not the, it's the, what do you call that, man? The press type. I'm not getting the name for that.
Clicking.
That type, you will find it has a proper stopper on the other end, which is rotated every time you click, and the refill comes out. The plunger type of refill, right? So, in fact, literally speaking, do you agree, using our definitions, the refill could also be called a unit? It gives a unit functionality for the pen. Technically, you can you can hold the refill and write, correct?
Yes, sir.
Yes, sir.
Yes.
So it does give you unit functionality. So you need not be so hard and fast about this. I've given you some kind of an idea, and depending on the sophistication level of the technology, we can try to understand the functional capabilities. Okay. Then now let me take a plunger pen, ball pen, where you have the plunger which you click, and the refill comes out. Okay. If you look at various functional capabilities, do you agree the plunger itself is giving you some unit functional capability of pushing out the refill and taking it back?
Yes.
But can the plunger alone take the refill inside back?
No.
No.
No. See, the plunger, if you see, it will resemble a cam kind of a thing. Okay. So when the refills non-writing end touches that, it rotates. That's why the refill comes out and then goes in. So what other part is there to enable the plunger action to pull back the refill into the body?
Spring, sir.
Springs.
The spring is there, isn't it? So the spring is a part. You will not call it a component. Okay. Whereas the other things are components or parts assembled together, the entire refill assembly. And then you get a sub function, a subsystem, the refill ejection and what do you call it, intake subsystem, if you want to put it that way, even in a pen, even in such a simple object. Have you understood this concept of system, module or subsystem, unit and assembly, component and part? Is that clear?
Yes, sir.
Yes, sir.
So from the point of view of maintenance engineering, in your fault tracing charts which you can have, which will help the maintenance team. By the way, I hope you understand why those charts are helpful, because once you visually display the fault tracing or the fault trees to show the logic of how failures can happen or something can go wrong in the functional capabilities, it need not always be a failure, it can be a deficiency in the running of the machine. It need not fail. For example, something going wrong might make the machine vibrate more, which you don't like because it can have an effect on the quality of what you're producing. The machine is running, but it's not running properly. It's like that. So in that case, the charts will enable any maintenance staff to understand what's happening. I'm presuming you have qualified staff. Okay, so remember, visual display of all that you do, of the work that you do, has its own benefits, that it's not person dependent. So the visual display can help a qualified person to quickly act on what should be done. You would have seen that in many Hollywood movies, sometimes there are visual displays and somebody who is reasonably acquainted will come and use the visual display and start operating something. Correct? So don't forget this. So this kind of a mental model, the structure from system to part, is useful from the point of view of fault tracing and constructing fault trees and so on, so that you are able to understand what are the possible ways in which something could go wrong in a machine. So it aids your practice, your engineering practice. Is this clear, please?
Yes, sir.
Yes,
Yeah.
sir.
I hope the class is also clear about this this system, I mean this mental model of science, engineering and technology, right? Okay.
Yes, sir.
Now,
Hello, sir. Excuse
we
me,
do
sir.
differentiate. Now, when do we use the term infrastructure? When do we use the term infrastructure? We often say, no, in the colleges that you would have studied in, we use the term campus infrastructure. So what do you call, what are those things that constitute infrastructure?
The rigid shape,
Pardon?
the rigid shape of something,
Oh, you
like
went
the
very
fixed
deep. You went very deep. Is it
buildings.
who gave
Avinash.
Avinash?
Avin.
Gave the answer. The answer is correct, Avinash. But on a lighter vein, your answer is correct. But it's like the definition of a machine, even in the movie Three Idiots. You understand? No, you gave a very sophisticated answer. You're not wrong. Okay. I just want you to understand this. Give us, Avinash, try a very simple thing. What do you call as an infrastructure? Use simple terms, Avinash. You can. The answer is inside
Physical
you
space.
already. Yeah.
Physical space.
And
Space. Yeah, correct. Spatial infrastructure. Definitely, I agree with you. But what is it that encloses the space? The buildings, na, Avinash.
Yes, sir. The buildings.
So the buildings form the infrastructure. There are many things like that, no? The building, again, you can look at the system in a campus. If you take the campus as a whole system, there are many subsystems in the campus. Do you agree? You have the water supply subsystem, you have the electrical power subsystem, you have the instrumentation subsystem, you have the, what do you call, the road subsystem, the pathways, the road and pathways subsystem. Okay. So like this, you can use the same model. But infrastructure, ordinarily we talk of things like the buildings and their utilities like water, connectivity, electrical connectivity, today net connectivity, plumbing, I mean, sorry, I did say water and plumbing, electrical connectivity, net connectivity, safety devices, fire safety devices, elevators, so many things are there inside a building. So all those things you call as infrastructure, and you not only have basic supportive infrastructure like classrooms, which consists of built space and chairs and a board, cameras, projection devices, lights, so many air conditioning systems. See, if you take a sophisticated classroom today, you can see how many subsystems are there. There is an air conditioning subsystem where I am teaching from. There is a projection subsystem where I am teaching from. There is a lighting subsystem. There is a seating subsystem, isn't it? Like that, there are many things. In fact, I am teaching from the studio where there are other sophisticated subsystems, including the recording subsystems and the communication subsystems, because there are several computers and other devices right here, isn't it? So please understand, while we use the term infrastructure, you will also now understand, based on my discussion with you now, that infrastructure itself consists of many technologies. I just gave you the example of a classroom. Just imagine a sophisticated classroom with so many technology subsystems. The camera, which is now sort of telecasting my lecture to you, is a subsystem here. It's a part of the video capture and telecasting subsystem, right? It's a sophisticated class. Sometimes you have classes where even the seats have certain functional capabilities. So this model is very useful, and I hope you agree that in our kind of a course, things could go wrong. Not because something is worn out, but sometimes the settings may not be correct. Okay. Occasionally, it has happened only once or twice. I come here and say good morning, and then I realize in some time that you guys are not responding. So I infer that you might not have got the signal. Then we check up whether everything is okay, isn't it? So sometimes the settings could have the issue. You might have to set something correctly. And this kind of a thing happens with your mobile phones very often. You don't do proper settings and they say, "Arey, ye kaam nahi kar raha hai." This is not working. And then you find out some friend comes and says, "Arey, ye setting dekho, ye karo yaar." Isn't it? So then you start correcting it and say, yeah, it's working. So it's not that something is not working because it's faulty. Something could go wrong because settings are not right. Okay. So please understand that aspect as we go along. Are we clear about infrastructure now? What constitutes infrastructure?
Yes, sir.
So in a hospital, what would constitute the infrastructure? Straight away, one answer you already have: the buildings. What else
Beds.
could be the infrastructure?
Beds, medical
Pardon?
beds. Medical beds.
The beds, okay. The hospital facilities, the medical beds. Well, go ahead. Do you agree?
Medical instruments.
Operation
Equipments.
theatre. Operation theatre is a part and parcel of the infrastructure of a hospital. Correct?
Yes.
What about scan rooms? Scanning is done in rooms. What about testing rooms? Laboratories. So the hospital infrastructure consists of so many subsystems involving so much of technology inside. Correct? So infrastructure is a generic term which is used, infrastructure, because infrastructure provides the base for your functioning, right? And that which consists of technology, and there are many materials. Now you know why I wrote materials, because materials constitute both capital equipment and consumables. Okay, that's why we group them together as a resource: technology, infrastructure, and materials. I hope this is clear. This resource is clear.
Yes, sir.
Yeah.
Yes.
Now, last point: what could go wrong with materials? Simple. What could go wrong with materials?
Materials of low quality.
Sorry, one of you, please. Mohanraj, yeah, go ahead.
So materials of low quality.
Low quality, correct? So obviously, that's why even when materials are incoming into your plant, you have an incoming quality check. Some supplier has given you some materials. How are you confident that they conform to your quality requirements? So you have your own quality checks and processes to take a accept reject decision, correct? Accept the materials or reject the materials and send it back to the supplier saying that this is not what I want, right? So all these aspects have to be taken into account in the functioning of maintenance management. Maintenance management is not just maintaining the machines alone, which is the core, but you have so many other aspects. What if the supplier has supplied to you low quality lubricants or low quality greases? Obviously that's going to affect your maintenance effectiveness and also the efficiency. So you have to check for the quality. What about instruments that you may use for judging the performance of a machine? So you have many instruments to check vibrations, acceleration, amplitude, etc. What if they are faulty? So this is a very good lesson I am sharing with you today, and then we will close. Always go with the assumption that things are not correct and things are not working. And then if they work, it's a bonus for you. Now that way, that skepticism will make you a better engineer, in fact a better scientist also, and a better technologist, because science demands skepticism. That small doubt you must have that something may not be right. So then you work more intensely to see to it that everything is correct. So this is a part of your character as a maintenance manager. Skepticism and the holding of skepticism is a part of your character, and it's good character, not bad character. Okay? Because you can still be a very good human being. You may even ask, sir, do we use the same skepticism in our lives, in our relationships? The answer is actually yes. But skepticism should not transform into deep doubt. Then it's dangerous. It's absolutely dangerous. Don't do that. Skepticism means you're accepting the possibility that something may be amiss. I hope you understand this point on what is skepticism. Are we clear?
Yes, sir.
Okay. So thank you very much. Have a great weekend, and we will meet on Monday.